Okay, so we will continue with 1.4, which is the inequalities containing two inequalities. Okay, the title is a bit funny, but it's actually an actual scenario that we can see. All right, let me just bring up my pen. Okay, so if let's say I have inequality in this form, okay, how do I solve it? Okay, I've written the steps over here. Number one, split the inequality using the AND operator. Okay, so I need to re-emphasize again that this is the first time in the whole notes that we are seeing the word AND. So what is AND used for? AND basically signals an overlap. All right, so if I break up this, okay, I can use the AND operator to represent it. Okay, I will try to highlight the importance of AND when I do the following question. Okay, some of you might not see why I need to use the word AND here. Okay, so it's okay. So after I split the word AND, then I solve the inequality individually. And then step 3 will be to recombine the two solutions using the overlapping region, which is again the use of word AND. Okay, so now let's solve this example over here. Okay, using the steps that was talked about. All right, so the first step, okay, is to split it using the word AND. So I have two parts, x plus 1 less than 4 plus 4x over x squared minus 2x plus 4 and 4 plus 4x over x squared minus 2x plus 4 less than 5. Okay, then I will solve each of the inequality individually. All right, so to solve this individually, okay, firstly, to make my life slightly easier, what I'm going to do here is I'm going to inspect this quadratic, which is in the denominator. Okay, always try to simplify your life by doing some manual inspection first. So in this case, if I inspect it, if I do a simple complete the square, I realize that this is always going to be more than 0. Okay, meaning to say that the denominator over here is positive definite. So if it is positive definite, I can multiply throughout. Or some of you know it as cross multiplication. So it will just be x plus 1 times x squared minus 2x plus 4. Okay, again. Then I expand the left hand side. This will be x3 minus 2x squared plus 4x plus x squared minus 2x plus 4 less than 4 plus 4x. Okay, simplify the whole thing. So x3, okay, minus 2x squared plus x squared will be minus x squared. 4x left and right can cancel, so I'm left with only minus 2x. 4 left and right can cancel, so this will be less than 0. Okay, so try my best to factorize this. So take out the x first. Okay, and I can continue to factorize this. Draw my number line. It will be minus 1, 0, and 2. Okay, put in my test value for the first region, positive, negative, positive, negative. Okay, so I need x less than minus 1 or x between 0 and 2. Okay, so this is my first inequality. So for the second inequality, okay, to solve it, same thing, I can do a multiplication throughout. So this will be 4 plus 4x less than 5x squared minus 10x plus 20. Okay, shift everything to one side. 5x squared minus 14x plus 16 more than 0. Okay, so over here, I will try to factorize it. Again, try to press the calculator, see whether there's roots. Clearly, there's no roots. So no roots, standard step, please complete the square. So 5x squared minus 14x plus 16 take out the 5, x squared minus 14 over 5 plus 16, and this will be 5, x minus 7 over 5 square minus 7 over 5 square plus 16. Okay, honestly, if there's no roots, you just have to show until here. You don't need to simplify it. And just say that this is always going to be 0, more than 0. It's positive definite. So, hold on. Does it mean that there's no solution? No, eh? Okay, if you look back at the original one, I want the values of x, which will make this expression more than 0. So actually, the solution is all real values. I can accept everything. Any x value I put it in, it will satisfy this inequality. Okay, so the final solution will be this and this. So the overlap of this and all real values. Clearly, the final solution will just be x less than minus 1 or x between 0 and 2. Okay, because this value itself is the actual overlap. All right. Can so this is how we solve an inequality containing two inequality. Okay, split it up using the AND operator. All right, solve individually, then recombine the solution using back the AND operator, meaning the overlap between this solution and this solution. Okay, let's move on. So what is the purpose of learning this? Okay, eventually leads up to this part whereby we want to solve inequalities containing the modulus function. Okay, so how do we solve inequalities containing the modulus function? Okay, there's two methods. Okay, the first method usually will meet a few resistance in using this method, but this is the simplest method to use, which is to apply the standard solution. So whenever you see, all right, a form like this, okay, or a form like this, you apply the standard solution. Okay, it doesn't have to be definitely x. It can be also written as something like that, fx modulus between 2. So if you apply the standard solution, will be fx between -2 and 2. Same thing if this can be gx more than 1. So the final solution will be gx, modulus, less than -1 or gx more than 1. Okay, can. So although the example here, the table here is given in terms of x only, but this standard solution can be applied to any function. All right, so the first method is to apply the standard solution. Okay, so the second one, I think most people will be more comfortable with this, but this is a very long and clumsy method, which is to square both sides, something that we learned in secondary school. Okay, can. So the rationale is if you square both sides, you eliminate the modular sign without introducing ambiguity. So I have a table here to summarize the instances whereby I can apply which of the methods. So if I have the first case, okay, fx modulus less than k, for example, will be something like this, then I'll be using method 1. If I want to choose method 2, also can. Means to say I can square both sides. So for example, I have 1 minus x less than 3. I can use method 1, which is to rewrite this as between -3 and 3. Or I can choose to square both sides. Both methods are possible. Okay, can. Same thing if I have type 2, okay, something like this, two functions. Example, something like this, I can still use method 1 or method 2. So if I were to use method 1, very simple. Same thing, 2 minus 3x less than or equals x plus 5. It'll be 2 minus 3x between minus x plus 5 and x plus 5. So we apply directly the same thing. Okay, of course you can also square both sides. Okay, the last case, something like this, two functions left and right, but both has modulus. Unfortunately, you cannot use method 1, you can only use method 2. Okay, so the note here is saying that although method 2 seems like a universal method, but it increases the order of the polynomial. So it's actually very clumsy. Why would we want to solve something with higher order? Power 2, power 3. No. Method 1 is always the preferred choice, unless you hit case number 3. Okay, I don't want to emphasize this anymore. You have to follow me, you have to believe me. Okay, method 1 is the best choice if you are given case 1 or 2. Okay, don't go around squaring both sides. Okay, so let me show using one example. Okay, so we have this example. Okay, so this is this case. All right, hopefully everybody can see. Same case. All right. So what we are going to do is we're going to apply the standard solution. So it'll be x minus 3 over x minus 1 between minus x and x. So we land ourselves with an inequality that contains two inequalities. Okay, so this is the reason why we have to learn just now that part. So following the same method, we are going to split it up. And all right. Okay, and we are going to solve them separately. So today we cannot cross multiply or we cannot multiply throughout because the numerator and the denominators are all unknown. We cannot confirm whether anything is positive or not. So the only way to do it is to bring it over. Okay, combine. All right, simplify. Okay, then of course we will factorize. So factorize here, this will be, the top part will be x minus root 3, x plus root 3 over x minus 1 more than or equals 0. Okay, so if we were to draw the number line, okay, there will be 3 roots over here. Okay, which will be minus root 3. Sorry, yeah, squeezing a bit. And we have 1, and we have a root 3. Okay, positive, negative, positive, negative. So since we only want the positive region, okay, we only take the positive region. So x will be between minus root 3 and 1, or x must be more than root 3. Okay, but take note over here because there's an equal sign, so we have to follow the equal sign. So which one can follow the equal sign? The root 3's can follow the equal sign. Okay, because the 1 is in the denominator, so it cannot have the equal sign. So x between minus root 3 and 1, or x more than or equals to 3. Okay, and so next, for the next part, and okay, so for the next part, we are going to solve the same way. Okay, I think there won't be enough space, so I'm going to cut short. So same thing, I'm going to combine and combine everything. I'll get x squared minus 2x plus 3 over x minus 1 more than or equals 0. Okay, so for the numerator, if I check for the factorization, I can't factorize it because there's no roots. So what I can do is to complete the square and show that it's always more than 0. So if the numerator is always more than 0, so if I want the whole expression to be more than 0, so the only thing is I need is the denominator must be more than 0. So over here, this will be x more than or equals to 1. So take note, I solve to the last part, there must still be an n word in between. So I want to find the overlap between the two solutions. So let me try to do the overlap here properly for you. So I'll draw an overall number line. Okay, the first solution lies between minus root 3 and 1. Okay, and also more than root 3. So if I were to do it properly, minus root 3 will be a full dot, 1 will be empty dot, or more than root 3 will be a full dot. Okay, the second solution will be x more than 1. So the x more than 1 will be from here to here, the blue line. So by visual inspection, where is the overlap? Here lah, correct? So therefore, the final solution for the entire question is x more than or equals to root 3. Okay, and so that's it. That's how you solve a question involving a modular sign. All right. Then let's move on. Okay, another example. Okay, so if I were to do this, okay, without using the GC, we solve for this inequality. Okay, let me just run my stuff. All right. Okay, so to solve this, same thing. Okay, I'll try to factorize. So let's start with, sorry, I need the again. Draw. Okay, so with this, okay, I'll start with the inequality x squared minus 4x plus 5 over x squared minus 5x plus 6 more than or equals 0. Okay, I'm going to consider the factorization for the numerator and denominator. For the numerator, all right, cannot be factorized. Okay, so we need to show the complete the square, x squared minus 4x plus 5, which is x minus 2 square minus 4 plus 5, which is more than 0. Okay, so the numerator is more than 0. So if I want the entire expression to be more than or equals 0, so only the denominator needs to be more than 0. Cannot be equal to 0 because it's denominator. Okay, so from here, very simple. Just do a quick factorization. Right. And then draw your number line. 2 and 3, positive, negative, positive. So the answer will be x more than 3 or x less than 2. Simple. Okay, so don't try to bulldoze your way through such a question. Use some logic. Okay, can. So the next part, to hand solve this inequality, so very standard. So today, the substitution that you're going to make is x is equals to mod x. Okay, for this case, I'll just try to quickly demonstrate it. So mod x square minus 4 mod x plus 5 over mod x square minus 5 mod x plus 6 more than or equals 0. Okay, take note of the expression mod x square is actually x square. So you can change it to x square minus 4 mod x plus 5 over x square minus 5 mod x plus 6. Okay, this is if you do the substitution. So take note of this expression over here. Okay, but you realize that just by this substitution is not enough because the inequality sign is different. Okay, so if I want to solve for less than 0, okay, take note, because when you solve for the first part, when it is more than or equals 0, more than or equals 0, you were taking only these parts. So if I want to solve for less than 0, does it make sense to say that I just take the complementary? The answer is yes. So to do this, I need to take the complementary, which is between 2 and 3, and then also apply the substitution. Okay, can? So we'll do both. Okay, so in this case, I want to remove the modulus. So how can I remove the modulus? Okay, to remove it in a very safe way, okay, I can break it up into 2 more than mod x and mod x less than 3. Okay, so for this case, I've applied the standard will be x more than 2 or x less than minus 2. And this case will be x between minus 3 and 3. So once again, I'm going to do the overlap. Draw the number line. Okay, for the first one will be between more than 2 and less than minus 2. Okay. For the second one, x must be between minus 3 and 3. Okay, minus 3 is going to be somewhere here. 3 is going to be somewhere here. Okay, so it will be here all the way to here. So where's the overlapping region? Here and here. That's right. Okay, so what's my final solution? Okay, final solution, very simple, will be x between, okay, let me just minus 3 and minus 2, or x between 2 and 3. Okay, can. So you see, my final solution will never ever have an n word there. If you simplify enough by considering the overlap, it will always be your r. The solution can either lie between minus 3 and minus 2 or between 2 and 3. Okay, can. So that is how you solve an inequality with a substitution that requires you to substitute in a mod x. Okay, so let's move on. Solving inequalities using graphical method. Okay, so this is the second part. Okay, graphical method actually very easy. This overlaps with your graphing techniques. Most importantly, you must be able to draw the graph. Okay, can. So of course we have our GC, which we can use to draw the graph. Okay, can. So we are asked to sketch the curve of 3 plus 2 mod 2x plus 1 over x minus 1. Okay, so I'm going to do a quick sketch. Okay, actually to sketch this, you can use your GC lah. Okay, no problem. Okay, I'm not going to go into details. So I'm going to draw the graph. Okay, there's a asymptote here, y equals to 5. Okay, and then there's a vertical asymptote here, x equals to 1. All right. Okay, then this part. Okay, can. So this is the sketch itself. Okay, so next part, we are asked to solve for this inequality. So how do we do it? Okay, so of course, to solve for this inequality, actually, secondary school, we have seen such a question before. We already have an existing graph. The existing graph is this equation. So we must at least make the existing graph equation appear on the left-hand side. So starting off with 2x plus 1 over x minus 1 more than x plus 5. So simply I add a 3 to the left hand side. So if I do that, I will also add a 3 to the right hand side. So I need to draw this graph and this graph. This graph I already have, therefore I just need to draw y equals to x plus 8. Okay, can. So I'm going to draw on the graph. Okay, can. So from the calculator, okay, from your GC, okay, you can predetermine the intersection. All right, I just need the x value. This x value here will be negative 3.65. This x value here will be 0.606. And this x value here will be 1.65. So what do I need? I need the parts whereby this graph, the red graph, is more than the blue graph. So which region is the red graph more than the blue graph? Let me highlight it. This region, correct? This part is more than the blue graph. This part is more than the blue graph. This part is more than the blue graph. So what's my solution? My solution will be x less than minus 3.65 or x between 0.606 and 1 or x between 1 and 1.65. Okay, so this is my final solution. Take note, I included the value 1 here. Okay, because why? Because 1 is the asymptote. The value cannot be taken up. So I must split it up to this region and this region. So this region is between 0.606 and 1, and this region is between 1 and 1.65. Okay, so using graphical method, very simple. Just make sure you have the graph properly drawn. Know how to use your GC to find the intersection, and then find the proper region that you want. Okay. All right. So now to the last question for the day. Okay, for the last question for the day, I'm going to demonstrate more of a particular question. Particular, not a killer. Particular question. Meaning what we want to do here is we want to solve for unknowns within the inequality. We don't want to know the inequality itself. We don't want to solve the inequality itself, but instead we want to solve the unknown inside it. So let's look at this question, a very common question. Okay, memorize it if you need, know it if you need, practice it if you need. Okay, I'm sure you can regurgitate it in the exam. All right. So we have this inequality. We want to find the range of values of k. Okay, so we are going to start off the question as how we are going to solve the inequality. Okay, we are going to simplify it and try to shift everything to one side first. What's the reason? You know it in a while. So for this question, to really simplify it, there's a very easy way. What you can do is to multiply x minus 1 squared throughout. Why can we do that? Because we know that x minus 1 squared is positive. So if you do that, this can cancel, and then this can cancel. All right, so I'm left with x minus 1 times 1 plus 2k minus kx less than k. See, if you use some logic or you practice some of the shortcuts, things will be fairly easy. Okay, can. So same thing, I'm going to shift everything to the left hand side. So I'm going to expand and shift everything to the left hand side. I'm going to get kx squared minus 3k plus 1x plus 3k plus 1 more than 0. Okay, can. So we want to actually solve for the k value. How can we do that? Okay, so the trick actually lies in the analysis of this inequality. We want this expression to be more than 0. So if you treat this expression as a graph, what happens when a graph is always more than 0? It simply implies there is no real roots, right? Secondary school concept. So if there's no real roots, what's the first thing you think about? B squared minus 4AC must be less than 0. So the coefficient of B will be 3k plus 1 square minus 4 times A, which is k, C, which is k plus 1. So from here, you land yourself with an inequality, another inequality that contains only k. Okay, can factorize out the 3k plus 1. So inside left with 3k plus 1 minus 4k. All right, so this will be 3k plus 1 minus k plus 1. All right, so what do we have here for the solution? Number line out will be minus 1/3 and 1. Okay, so put in the test region positive, negative, positive. All right, oops, let me take a look. Oh, sorry. This is if I put in a test region, this is not going to be like that. Okay, because of the negative there. Sorry, my bad. Because of the negative here, so if I put in a test region, this should be negative, positive, negative. Okay, so I put in 10. Okay, 3 times 10 is 30. 30 plus 1 is 31. Minus 10 plus 1 is minus 9. So 31 times minus 9 is negative. So the first region starts off with negative. Okay, so what is the solution for k? K will be less than minus 1/3, or k must be more than 1. Okay, can. So is there, let's see, is there any other condition that we need to have over here? Let me see. Okay. So there's actually a hidden condition, because if you look at this, if you look back at this inequality here, this inequality here, okay, we say that in order for this to be more than 0, it must be in this shape. But what did we assume over here? We assume that it is U-shaped. Okay, this assumption here is ambiguous for this case because the k is in the coefficient of x squared. So for us to assume it to be a U-shape, okay, and more than 0 and no real roots, k must be more than, so it must, there's another solution which is n, k must be more than 0. Okay, this whole question will not work if it is n-shaped, because if it is n-shaped and more than 0, at some point in time, it will cut the x-axis. So it doesn't work if it is an n-shape. So there's a hidden condition whereby we need to put k more than 0. Okay, so once again, I overlap these two solutions. Okay, so the first part of the solution is, let me just write here, less than minus 1/3 and more than 1. Okay, the second part of the solution is more than 0. So 0, I'm going to put it here. And so where's the overlapping region? It'll be here. So therefore, what's the final answer? The final answer I'm going to write here, k will be more than 1 because of this overlapping region. Okay, can? So hopefully you can see how to solve this inequality with unknowns. Take note, over here we're not trying to solve the inequality itself, but we are trying to solve for the unknown inside the inequality. Okay, so the initial part will be the same step. We try to shift everything to the left-hand side. We try to factorize, and we come to this equation over here. Okay, so this is the part whereby we know that we need to apply that it is a U shape. Okay, and if it is more than 0, then there will be no real roots. Okay, Ken. So I'll end my lesson here today. So everybody stay safe. Okay, and please practice proper social distancing, and we will see one another again real soon. Thank you so much. Bye-bye.